Hello everybody, my name is Jean Hertel and I'm going to introduce you to adriconf. So first of all, who's this guy, this beautiful face you're seeing? I'm basically the person being devoted by a shark. As you can imagine, I like to be fun, or pretend to. I'm a Brazilian, just in case you're wondering. I mostly work on PHP and closed source stuff, so you won't see my name much everywhere. And I basically love Linux. So, first of all, why do this software? Why do this change? So, basically motivation is I want to contribute something to MESA, so to also give something to it. adriconf was an open source project, and it was there like waiting for some X.Org, some Google Summer of Code student to pick it up. And I guess it was there for, I don't know, 5-10 years. It's a long time already waiting for somebody to pick it up. Nobody was ever going there to do it. Yeah, and adriconf didn't catch up with recent change, so it doesn't support Rime, doesn't support a lot of things. It's like super outdated. And basically I don't know Python, and just in case adriconf, it's a bunch of Python scripts on top of xdrinfo. And since I don't have Python knowledge, I decided to go C++ and rewrite everything from scratch. That was the basic idea and motivation behind it. By the way, I didn't make it as a X.Org project because I was not eligible. I already have a degree, so I just decided, okay, let's just do this and yeah, see how it goes. Cool, let's take a look on how the MESA configuration works. So everything in MESA, it's XML based. So as you can imagine, both the configurations we write down as the ones we get from MESA. So how does this look for the user when they're configuring something? So they write basically an XML file with this root element, adriconf. And then there is one of the most important ones, which is the device, which is the screen and basically the driver, which is the MESA side driver name. Because, for example, Radeon, it has also the AMD GPU, which is like on the kernel side, so you can have like different drivers. In this case, it's always the driver name from the MESA side of things. Then you can define any number of applications. In this example here is Tux Racer. In case you don't know, it's a game for basically kart racing. And inside an application, you can define options. And those options can be like anything supported by the driver. You could also write things not supported, but yeah, it will be ignored anyway, so not much reason for that. Cool, let's take a look how MESA does it. So when you query MESA, they provide an API that you can query to get what options a specific driver supports. And basically MESA returns a response also in XML that looks like this. So has a root element, adrinfo, has a bunch of sections. Here I'm showing just one, but it has usually 4 sections. Inside each of them there's a description which says, well, a description basically saying what is this section about. And it has translations, so all this text is available in MESA as spot files, so you can go there, you can change or add translations if you want. And I don't know how many languages are supported, but I guess there's only 5 or 6 languages supported, so in case you're missing them, go there and just translate it. And then there's also the options, and this is the most important thing, which basically defines what this driver really supports. And basically all of them have a name, which is what MESA will query later, a type, which I'm going to talk in a minute, and then have default and valid values. And in this case inside we also have a description of this option. So in this case in English means a buffer object we use. And then you also have, since this is an enumeration, we have the enumeration values. So in this case enable and disable. It's more or less a Boolean option, although it has like proper descriptions for it. Cool, that being said, let's look at things from a MESA perspective. So how exactly MESA gets the data out of users' computers? So first of all, it parses everything that is inside the data here. and this is /dirc.dir, and everything that is inside there it's alphabetically sorted, and basically it reads everything. Then it parses the dirc file, which is in the sysconf dir, and then finally it goes to whatever the user defined in his home directory. And it really parses all those sources, and it's this exact order, and it always replaces the options with the subsequent ones. So if we define something in the data dir and later we define it again in the user dir always takes preference. Cool, and in case you're wondering, those crazy names, data dir and sysconf dir, they're defined at compile time by MESA, so by default I have the values here. And we also offer those options as compile time options in adriconf, because we basically need to read from the same place. So in case you are custom compiling MESA, you can also custom compile adriconf and have basically the same options. Cool, that being said, let's take a look how previously things were looking at adriconf. So this is basically it, in case you missed it or you never saw it. And it has a bunch of problems. Let's quickly go through them. So first of all, it has a quite confusing UI. And with confusing, I mean, if you look at this screen, it's full, there's a lot of options and combo boxes everywhere. And that's because there's actually two very different things happening here. The first one on the top and in blue, it's basically the default profile, so options that are applied to all applications. And on the second part, there is the application specifics or custom profile. So you can go there, and in our previous example, for example, the Tux Racer, it would appear here. So that's one source of confusion because things are mixed in the same screen. The next problem is regarding Prime. So as you are quite aware for, I guess, more than 10 years now, there's like a lot of laptops, for example, that usually tend to ship with an integrated graphics card and then a discrete one. So you have two cards, but then it's quite complicated because if you don't support it, so it's like, it doesn't work. So, and with doesn't work, I mean, you can still go and write the file by hand, but that's, I mean, that's not very friendly, so to say. So it's easier if the adriconf supported it, but it doesn't. Which brings us to the next one. So as I mentioned before, the user configuration is defined in this .dirc file, its home directory. And MESA ships by default a file called 00 MESA defaults. And that file is basically used by MESA developers when they need to ship a fix either to a game or another application, and they can literally put anything there. And literally they do, there's a lot of good defaults there and options. And this is basically to improve performance and make it work better. But the problem with adriconf is that whenever you add an application profile or change something, it goes and writes a full file in the home directory, which essentially means whatever it's now shipped by MESA developers as a fix, it doesn't apply anymore because MESA always takes precedence from the file that is on the home directory. So in case you use adriconf, basically you nullify any future improvement that MESA developers do. And that is one of the biggest problems. And I guess it's also a reason why a lot of people started to tell users to not use this application anymore, because it's simply making useless whatever efforts MESA developers do to fix or improve applications. Yeah, it's a facepalm. That's why the meme. Cool. The next thing. Oh, by the way, it was not properly maintained. So last time I saw some activity was in 2007. So it was like, yeah, there's nobody looking at that anymore, or at least not. I couldn't find it in any repository activity or anybody doing anything with that, and that's also part of the problem, I guess. Cool, which brings us to the next topic. And before anything else, cool, thanks. Say hi to adriconf. This is how it looks basically, and let's go quickly through its features of how we are improving on top of what adriconf was providing. First of all, the UI. Hopefully it's a bit more user-friendly. So trying my best to make this as useful and as intuitive as possible. And as always, if you have some issue with it, or if you find something that is not working as you expect, or you think it's confusing, feel free to open an issue. I'm more than happy to discuss or take a look or improve anything. It supports Prime, so in case you have multiple GPUs, we support View. There's also some merge logic before writing the options, and I guess it's interesting for us to dig a bit into it. Basically, we follow the same logic that MESA does, so we read configurations file from the system-wide directories, we merge everything, we also look at what is the driver default for that option, and we only really write those options down in the dir.irc file when the option that the user changed is different from a default or already defined option. So if, let's say, by default, TuxRacer has an option saying true, and we only write it down if the user goes and say, okay, this option should now be false. This is a bit tricky, because if the user really wants the option to be false, to be true, we don't write it down. We depend on the default, but I think that's also an advantage, because whenever MESA developers understand something is broken and it's better for it to be false, they can just change, and now everybody receives the benefit of it. Cool. What next? Oh, there's a maintainer. That's me, just in case. Cool. Let's take a look at how the UI works. So, how everything fits together. As I mentioned before, we have those sections, and those are basically designed as tabs on the left. So, and whatever comes as the description. So here I'm running adriconf in English. So if you run it in German, you see the options in German and so on. Of course, depending on what translations are available on MESA. Then we have the option description. This is basically, well, I guess the name says everything. Whatever the option is defined, and again, it's dependent on what MESA defines for each option, what the driver developers set. And then comes the type. And yeah, the type, let's take a look. What about them? So there's a bunch of those. Basically, we support booleans, which we draw as this nice click button. There's integers, which basically we design as this small box that you can increase and decrease. And there's also enums, which basically we draw as combo boxes. Technically, MESA also supports floats and strings, although I never saw any driver using it, so we don't support them on adriconf, basically because I never saw them. But if you intend to add one of those, or you see any driver that uses it, feel free to ping me, and I'm more than happy to think how to better drive them, or how to better design to show them beautifully in the screen. Cool, and how did we get there? That's an interesting part. So initially, there is those two functions that were introduced in 2006 by Felix, together when he introduced adriconf. And this is basically to get the driver and whatever driver config is available. That's not part of any OpenGL extension, and that's a huge problem. And the reason for that is when you ask MESA to give you a function pointer, which is the way you get it, by the way, MESA will always return you a function pointer, and that's cool from MESA part because it's a smart way of implementing it, so there's less overhead, and it only does the lookup and really gives you the proper function when it's called, so there's a virtual lookup table. The problem with that is if the driver doesn't support those functions or doesn't expose it, you basically never get it. So you get a function pointer that is valid, and when you use it, basically the application will segfault. And I saw this happen by myself. So that's how I know it's super broken. So since it's not part of any extension, there is really no way to test if the function is available and the driver implements it. Oh, by the way, it also doesn't work under Wayland. And by that, I mean, technically you can still call them when you are under Wayland, because, I mean, there's the X11 wrapper and everything around there, the X Wayland, but it's I mean, everybody's moving away from Wayland, so we shouldn't be relying on GLX functions anymore. We should move everything we can to a Wayland, more agnostic way. And so yeah, those functions are also not very nice in that regard. And yeah, this was basically main problems with it. Although we initially used them, that's not exactly enough for us. Which brings us to a new extension. So we were in need to have a proper way to query those things. And this introduces us to EGL MESA query driver. And this extension has this signature. Basically, we take a EGL display and then basically look up whatever is the driver name and the driver configuration available, if any. And they're very similar to the GLX ones, with the exception of the get driver configuration, which before was just taking a driver name. You could literally pass anything. Now we take a proper pointer to a display, which is much cleaner. There's the official specification link in case you want to take a look. I'll share this presentation later. But this extension was not done by me. So it was originally introduced by Veluri Mitun with the help of Rob Clark and Nikolai Handley. And Veluri is basically an EVOC student from 2018. So he made this endless vacation of code, contributed a lot to adriconf, not only this extension to MESA itself, but also contributed to Flatpak packaging. So now, yeah, we have a proper Flatpak. Also wrote a bunch of unit tests, so made in general a lot of improvements to adriconf in general. So thanks Veluri for that. Cool, you can get it on Flathub in case you want. So it's available there. And for the future, so where we want to go with adriconf, first thing would be Vulkan support. I didn't have proper time to really dig deeper into Vulkan, and I should because it's some years old already. Basically, I guess I will hook some extension up in the VK physical device, likely query from there. But yeah, I need to really take a look on the API, how it works. And Vulkan introduces a very nice feature, which is you can tell what is the name of the rendering engine you're using. And MESA devs are quite smart because they already expose this also in the configuration. So when you're under Vulkan, you can actually set a configuration for an engine, which is super cool because now you can apply a configuration that is for a general engine. Let's say Unreal Engine has something that is, I don't know, works better when a specific option is set. So now we can go and set this by engine, which is a very interesting addition. And of course, we want to also support that. And finally, but not less important, is usability improvements. So my understanding is that adriconf is not perfect, and I want really to improve it and make it more and more user-friendly. So I'm trying, whenever I have time, to take a look, try to figure out how to make it better. And yeah, hopefully it will get better with time. So if you have any hints or insights or something you think could be better in that application, feel free to ping me, to open an issue on GitLab, and yeah, I'm always open to hear. And yeah, that was it. Thank you for your attention. And if you have any questions, feel free to shoot them.
So hello, we are here live with the author of the presentation, and indeed we have a couple of questions from IRC. So the first question is, what UI toolkit has been used?
I used mostly GTK MM, so GTK Blues, basically.
Okay, thanks. Another question is, do you have a database of all possible configuration options?
No, so basically each driver can define the configuration day one. That's why we need those extensions to basically query the driver. And yeah, that's it. Basically we query them, and then the drivers return whatever options they support with the proper descriptions. And this is the way also an area, if anybody is interested in contributing to translations, because I saw 1 or 2 languages supported, but many are missing, and MESA has translations for all those options. So if you're missing anything, MESA is the way to go.
Okay, so that means you also get the human readable strings for those too.
Yes, yes. You get the exact description on everything that appears on the screen. Most of the text comes directly from querying MESA.
Okay, so I guess this is it for the questions. Thank you very much for your presentation and for working on the tool. There are a couple of people on the IRC that also seems to be really appreciative. And that's it.
Thanks.
Yeah, thanks.
Cool. Thanks, guys. See you around.